Our entire digital world is built on a network that basically treats every single task the same. It doesn't matter if you're streaming a 4K movie or just sending a simple text, but that is all about to change. Today, we're going to dive into a concept called network slicing, a truly revolutionary idea that's quietly redesigning our connectivity to finally move us beyond that one-size-fits-all world. So to really get why this matters, let's start with a simple question. Have you ever felt like your internet connection just wasn't built for what you were trying to do? Well, that's because, for the most part, our networks have always had this one-size-fits-all approach. And honestly, the cracks in that model are really starting to show. You know the feeling. You're at the most critical, intense moment of a movie, and there it is, the dreaded buffering wheel. This is such a classic example of a general-purpose network just struggling to keep up with a high bandwidth demand. Or how about this one? For gamers, even a fraction of a second of lag can be the difference between a glorious victory and a frustrating defeat. This just highlights the desperate need for connections with incredibly low delay or latency, and that's a guarantee a standard shared network just can't always provide. And this isn't just about our entertainment. I mean, what happens when an entire city needs to connect millions of tiny, low-power sensors to manage things like traffic or air quality? A traditional network can get overwhelmed by that massive scale fast. So we've got problems with bandwidth, we've got problems with latency, and we've got problems with scale. The solution isn't just a faster network, it's a smarter one. And this brings us to a whole new way of thinking, slicing the network. Okay, so what is it exactly? Well, network slicing allows us to take one single physical network and create multiple completely independent virtual networks right on top of it. And here's the crucial part. Each one of these virtual networks, or slices, can be custom-built and optimized for a very, very specific job. The best way to get your head around this is with an analogy. Think of the physical network, all the fiber optic cables, cell towers, and routers, as one giant highway. Network slicing lets us create dedicated virtual lanes on that highway, and we can tailor each one for a very specific kind of traffic. So what do these virtual lanes actually do? Well, they generally come in three main flavors, and each one is designed to solve one of the problems we were just talking about. All right, here they are, the big three. You've got EMBB, which is all about pure speed. Then there's URLLC, which is for absolute rock-solid reliability and low delay. And finally, MMTC, which is for connecting a massive number of small devices. Let's break each of these down. First up is EMBB, or Enhanced Mobile Broadband. This is the super-fast, multi-lane express portion of our virtual highway. It is built for one thing and one thing only, moving huge amounts of data as quickly as possible. This is the slice that will finally kill video buffering for good. It's built for immersive VR and AR, crystal clear 4K streaming, and even for delivering fiber-like internet speeds to homes, but wirelessly. It's all about maximizing that bandwidth. Next, we've got URLC. It's a mouthful, I know. It stands for Ultra Reliable Low Latency Communications. Think of this as the emergency vehicle lane. It's not necessarily the fastest lane, but it's incredibly reliable with almost zero delay. Communication is guaranteed to get through instantly. And the applications here, they're truly mission critical. We're talking about autonomous cars communicating with each other to avoid collisions, or surgeons performing remote robotic operations from thousands of miles away, or power grids that can react instantly to prevent outages. In these cases, lag isn't just an annoyance, it's a serious risk. And finally, we have MMTC, or Massive Machine Type Communications. Now, this lane is designed for a completely different kind of traffic. A huge number of slow-moving vehicles. Devices that only need to communicate tiny bits of information and do it really efficiently without draining their batteries. This is the slice that really enables the whole Internet of Things. It's built to efficiently connect millions or even billions of low-power devices like smart city sensors, agricultural monitors, and asset trackers, all without overwhelming the network. So creating these custom virtual lanes sounds great, but how is it actually possible? Well, the secret sauce is a combination of two really powerful technologies that have been evolving for years. As this quote highlights, network slicing isn't an idea that just appeared out of nowhere. It's really the ultimate result of this long-term trend in making networks more software-based, more flexible, and just plain smarter. Here are the two key enablers.
First, you have SDN, or software-defined networking. Just think of this as the network's brain. It's the central traffic controller that intelligently manages and programs all those virtual lanes. Then you have NFV, or Network Function Virtualization. These are the building blocks. It's what turns rigid, specialized hardware into flexible software, letting you build any kind of lane you need whenever you need it.
Now, this all sounds absolutely amazing, but the road to a fully sliced world isn't without a few bumps. So let's take a look at the challenges and the incredible future that this technology unlocks. The main hurdles really come down to complexity, security, and standardization. Managing thousands of these dynamic slices is incredibly complex. Ensuring that they are perfectly isolated from each other is absolutely critical for security. And, just getting all the different vendors' equipment to work together seamlessly is a huge undertaking. So how do you solve that level of complexity? Well, the answer is automation, and it's powered by AI and machine learning. The future network isn't going to be managed by humans clicking buttons. It's going to be a self-optimizing system where AI intelligently creates, manages, and even heals these network slices all in real time. So the crucial point is this. Network slicing represents a fundamental shift. We're moving away from treating connectivity like it's this generic, one-size-fits-all utility, and we're moving toward a future where it's a precisely engineered service. This changes the entire business model. Instead of just selling data plans, providers can now sell guaranteed performance, a slice for gaming with guaranteed low latency, or a slice for a hospital with guaranteed reliability. It's a move from selling a pipe to selling a promise. And that leaves us with one final thought. When we're no longer limited by our network, when we can instead build the perfect network for any idea, what new applications, industries, and realities are we going to create? The possibilities are just beginning to unfold.